It's time for our summary and commentary for the very last section of the technician class question pool, and that is section T0. It does kind of look like 2 on the screen, but this sub-element was about safety. So we will use our key takeaway slides to sort of guide us as we narrate this section. And we'll start with T0A, the power circuits and hazards. Black wire in the United States is a hot wire. Fuses go in series with the hot conductor only, and you never upsize a fuse due to fire risk. So if it's a 5 amp flow, 5 amp wire, use a 5 amp fuse. Don't upgrade to a 20 amp fuse, because you're basically putting something in there that's as strong or stronger than the circuit, and it will not blow. It'll just cause everything to pass through and cause electrical hazards. All ground rods must be bonded together. So if you do ground your equipment, it needs to be bonded with any other grounds, like your house, everything. It needs to all be bonded together using the strap wires or thick wires. That way everything has the same potential of ground, and you don't have this big loop going and then a lightning hit and it has a higher potential one direction than another. That would be somewhere you don't want it to go. Lots of books and videos and stuff out there on grounding and bonding, and it's sometimes it's a debated subject. Some folks just drive a ground rod in the ground and attach to it for their radio equipment and don't attach it to anything. And some folks, I've got friends that they don't ground the thing. They don't ground, they don't bond. They just plug and play, and that's HF and everything. But do your research on that when you start building your station, and make sure that you do that correctly. You don't want to cause any kind of electrical hazards that could cause a fire or anything like that. And lightning arresters go where the feed lines enter the buildings. Invest in some good lightning protection. It's there's stuff out there you can do that you can buy and set up. Don't just rely on insurance, as one of the other videos I've done will tell you. But get some good lightning protection for your equipment. Whether you stay a technician and you only operate 2 meter 70 centimeter or anything within that, or if you go any HF or anything like that. Capacitors in power supplies can hold lethal charges long after power is removed, so always discharge before servicing. And they're talking about DC equipment or direct current or house current equipment in particular. They will, even AC stuff, they're talking about alternating current type stuff will hold a lethal charge. DC 12-volt stuff typically doesn't, but either of those will hold a charge in the capacitors that can keep power to equipment, things like that. So especially if you're trying to reset something, see what the procedure is for discharging those capacitors. I know a lot of times on 12-volt stuff, you can just take like a screwdriver or something like that and touch the red and black leads together, and it'll discharge the capacitors. Don't do that though unless you read the manual and it suggests that. That's just something I know from working on cars years ago. You could do that and discharge the capacitors in a car computer by touching the black lead to the red lead, disconnected from the battery, of course. But that's my recommendation, is anything you have AC or DC powered, if you need to do that, but AC powered in particular could hold a lethal charge. So make sure that you know that those things have been discharged before you go messing around in there and potentially get shocked. And electrical current harms the body through heating, cell disruption, and involuntary muscle contractions. It can shock the heart, just like a stopped heart. In a medical situation, they shock the heart to try to restart it. It can have the opposite effect if the heart's beating like it's supposed to, and then it takes an electrical charge. And it also causes involuntary muscle contractions, which would basically prohibit you from voluntarily letting go of whatever's causing the situation. And of course, the last thing you want to do if someone's being electrically shocked like that is grab a hold of them and try to pull them away, because then it'll travel through to you. In order to separate someone from something like that, find something insulated and then try to remove them from it. Batteries can overheat and outgas when rapidly charged or discharged. Shorted 12-volt batteries can cause burns or fire. So when that gas emits in the air, it is flammable. There are a lot of 12-volt battery rapid chargers out there that if you do charge a battery rapidly, it has the potential of putting off gas, especially if you're talking about bringing like a car battery or deep cycle marine battery or something into your home to power your equipment with. Be careful what you use to charge that and how fast you charge it. I've always been told, and rule of thumb was that a slower charge, more slower deliberate charge was a more efficient charge. And then always verify that your meter and test leads are rated for the voltage you are measuring. These little cheap voltmeters and stuff, be careful what you use them on. They may be pretty good for 12 volt, but if you're trying to measure house AC or something like that, they may not be able to handle that. The meter, if it has little thin wires on it or something, the wires themselves may not be capable of handling that. So just best thing I can tell you is read the package, read the manual, and it will tell you what you need to know and give you warnings and all that kind of stuff. Those things are there for a reason. And then T0B, antenna safety. Never climb a tower alone. Always have a helper observer on the ground. No exceptions. At least one person. Somebody needs to be part of your ground crew. Doesn't matter how tall that tower is or anything like that. If it's a 20-foot tower, have somebody on the ground, somebody to help you in case you get hung up there or have an accident or something that they can call for help. And of course, they're handy to have as far as your ground crew. If you set up a system where you can send equipment up and things like that. Tower climbing requires training, continuous tie off, and approved harnesses. All three every time. I'm not sure where you can get tower training in my area in particular, but I'm sure there's plenty of things out there. I don't know that I would rely totally on watching a video and then trying to go out and climb a tower. The safety harnesses, they should have a continuous tie-off method. I'm not much of a tower climber myself, but I have helped, and I know the harnesses that I've seen used, the folks, they never detach at any point from the tower. There's two buckles or two clips or whatever that they can use, carabiners, whatever, and one's always intact. Once you reach its limits, then you can hook the other one in and unhook that one, and so forth and so on. Make your way up the tower, and always use approved harnesses. Be careful where you buy them from. Don't buy cheap stuff that's not made to hold your weight or not made to connect to a tower. And crank-up towers must be fully retracted before climbing. Extended sections can collapse, so there's a lack of structural integrity as far as the weight of a climber goes on those. And with that being said and in mind, just also know your tower's capability versus the weight of your antenna as well. A lot of really good, really light option antennas out there these days, but there's still some pretty heavy stuff. I use a hex beam, and I think it weighs less than maybe 20 pounds, something like that. If an antenna falls, no part should come within 10 feet of any power line, and survey before installing. So yeah, make sure that whenever you're putting up an antenna, whether it's a short 10-foot mast or something like that, or any size, just make sure that antenna can't come within 10 feet of a power line. If you're dealing with a heavy antenna or a tower or anything like that, and it gets to flopping around and causes you some problems, you think it's going to fall, don't try to catch it. The best thing to do is let it go, because you can replace that stuff. That happened to me when I initially tried to put up my hex beam. It wasn't a crank up tower, but it was a tilt over base, and something kind of went awry on that. And folks that were helping me, I immediately called out, let it go, and we broke a couple pieces off of it. I was able to find replacements and order them and put them in, and eventually get the antenna put up. Ground each tower leg with separate 8-foot rods and bond together. Avoid sharp bends and in-ground conductors. I think the explanation after the question explained that best, but yeah, 8-foot ground rods, bond everything together. The sharp bends can arc and cause the lightning to go somewhere you don't want it to. And then safety wire through turnbuckles prevents vibration and loosening guy wire tension, because that's one of the last things you want to have to deal with. Is you've got your climbing crew and whatever, or you put up a mast or something, and typically these things require some help, and then you get it up in the air, and a little while later, months down the road, everything starts to vibrate apart, and that can be kind of a pain. So let's go to C, takeaways. All right, here we go. T0C, RF hazards. So VHF and UHF signals are non-ionizing radiation, and they cannot cause radiation sickness, but they can cause RF burns. So yeah, just be aware of that even grabbing a VHF or UHF antenna, it's probably a little less common, but you can get some RF burns. You're not going to really get a radiation sickness from being exposed to it a lot. That's one of the reasons that we can do HTs and things like that in those bands is the RF even being in the room with you is not going to cause any kind of sickness, and rubber antennas typically won't cause the burns either. 50 megahertz has the lowest, most restrictive MPE limit. The body absorbs RF most efficiently at 3 to 300 megahertz. So yeah, the 6 meter band has the is the most restrictive, or has the lowest limit as far as the absorption of RF. I know from working the 6 meter band, it can be a little finicky and tuning. And I know the amplifier that I have, full legal limit amplifier, but it's a little more restricted on 6 meters, and that's part of the reason right there. 50 watts PEP at VHF is the threshold for requiring an RF exposure evaluation. I've never done an RF exposure evaluation in my 30-some years of amateur radio, but I've also never really exceeded 50 watts PEP. You can have a radio that runs higher than 50 watts on 2 meters. I had a Kenwood TS2000 around 100 watts, but the peak power, the PEP, may not exceed the 50 watt threshold, just depending on what power level you're running, antennas, length of wire, all that kind of stuff. So yeah, for that though, you would want to measure the PEP power, and if you're exceeding 50 watts, definitely look into one of these, the RF exposure evaluation, how you can do that. Duty cycle affects average exposure. Lower duty cycle modes allow higher power within the same limits. So the duty cycle for FM is 100%. You key up, it transmits the whole time. Single sideband is not. It's basically whenever you're speaking, the power is being applied. Whenever you're not, there's no modulation, there's no power applied. So it's somewhere in that 50% or so range, just depending. The mode, and there are some digital modes on HF, like FT8 would be 100% duty cycle. When it keys your transmitter and starts putting out an RF signal until it stops, it's on. Even though it's using sideband, it's modulating a carrier the entire time and putting out. So if you're pushing legal limit or anything like that, that's what you're putting out. Your average exposure goes up. And one example of that I can give is when I first purchased my amplifier and I was able to put out legal limit. I only used that on actual voice sideband, but on FT8 I would run a little bit of power. I'd run somewhere in the neighborhood of 600 to 800 watts, maybe 1,000, depending on where I was at, just kind of playing with it because the amplifier was capable. Well, one of the things that I didn't realize was the balance that I had purchased, the MFJ balance, even though they were rated for full legal limit, that was not for continuous carrier. So I immediately got the hint when the amplifier reduced power and the SWR went up after a few minutes of operating. So I walk outside to my antenna and check my connections, and I grab a hold of that balun, and that sucker is hot. Like, it's not melting, but it's hot. So I learned a lot in one foul swoop about getting baluns that are rated for 5,000 watts or something like that if you're going to run continuous carrier. Reevaluate RF exposure whenever equipment changes, such as antennas, power, or frequencies. I kind of probably just exampled that one right there on my HF radios. Once I added power, and I'd already prepared for it with the antennas and the coax, I just didn't realize with the balun, if I'd operated at SSB voice all the time, maybe even CW up to a limited amount or whatever, then I probably would have been fine. But that continuous duty cycle at that much power put the test to all of my equipment. So yeah, definitely reevaluate that. And then the station licensee is personally responsible for ensuring no one is overexposed to RF energy. And that's no one, whether it's your neighbors. And, I have antennas on my fence line that I have to make sure I have those up high enough that folks can't reach across and touch them. I've got kids, family, wife, whatever, that could be exposed to RF, so I do take precautions to make sure antennas are out of reach or fenced in or something to keep people away from them, especially my HF stuff where I'm operating legal limit power and everything. That's up to me as the station licensee. Same thing for you. Once you obtain your license and you're the station licensee, then that is your responsibility. If anything should happen, goes against FCC rules or anything like that, then that's who they will hold responsible for all that. So that is our key takeaways. That is our summary commentary for section T0C, and that is the final section. So at this point, if you have followed along every slide, every video, including the summaries, and you've got to this point, you have come to the end. My suggestion at this point is to take some practice tests online, and if you are consistently passing those with above average score, with the way above the passing score, then you're ready to take the test. If you're not, then get back in the book, get back in these videos, replay some videos, maybe even some of these practice tests will give you feedback on what areas that you are lacking in. Try to study those areas some more and just kind of go back through everything again. And then once you get your license, give me a shout if you're able to. My call sign's N4NT. I'd be glad to talk to you. If you want to learn more about the hobby, I've got lots of videos on this channel, and I plan on making a lot more. One of my particular areas of expertise, for lack of a better word, is the FCC rules and regulations and law, and I cover their enforcement, but I also have a lot of other stuff out there as well. So please check it out and leave me some feedback on any of my videos. I like to respond to viewer comments by making a video about those, so I typically don't ignore any of those unless it's a profanity-laced rant or something, then I'll probably remove it. But other than that, even if it's critical, I address it. So thanks for watching this series of videos. Good luck on your test, and I hope to hear you on the air sometime. Until then, this is Adam Dye, amateur radio call sign N4NT, saying 7-3.